We are on to a different type of example, okay? We are no longer looking for all solutions, we're just looking for all the solutions between 0 and 2 pi. And some of these questions are going to require a little bit more algebra. And that being said, this very first one is going to require us to do a little bit of factoring. Let's maybe think about this as 2y squared plus y plus 1, just so it looks a little bit more familiar, and it should be minus 1. If we were going to try and factor this, one thing we could do is we could just do guess and check. We could try 2y times y plus or minus something. Okay. And let's just try a couple different things out. We know we're going to need a 1 and a minus 1 because it's going to have to multiply to negative 1. So maybe let's try plus 1 here, minus 1 here. If we do this, we'll get 2y squared. Then we'll get plus 2y minus y, which will add up to just y. And then minus 1 times 1 will multiply to minus 1. So this is how we would factor this. And so next we want to just rewrite this in terms of sign though. So this 2 sine squared x plus sine x minus 1 equals 0 can now be written as 2 sine of x minus 1 times sine of x plus 1. Okay. And this is all equal to 0. Now, you might be wondering, well, why did we even factor here? Okay, why did we factor? Okay. We factored because at the moment, looking at this equation, there was no way we could think of isolating our trig function because we had 2 of them and one's squared and one's not. So how are we going to isolate sine in that kind of a situation? And the answer is factoring, because something really nice happens here. When you have a product, okay, of 2 things and they're equal to 0, then the solution to that equation is if we can just find where either one of those products or factors is equal to 0. So this is what we're solving now. In both of these equations, we'll be able to isolate the trig function. This first one, I could add 1 and then divide by 2 on each side. And this one, I could just subtract by 1 on each side, and we get sine of x is equal to minus 1. Okay. Now, we technically can use the technique that we were using previously. It's a little bit overkill here, but I'm going to do it in that fashion because maybe it'll make some of the later ones easier. So if we were to use our same technique from earlier, we'd jump to our unit circle and just think about where does sine of x equal 1/2. Okay. Well, sine of x is equal to 1/2 at pi over 6. And the other place is 5 pi over 6. So these are all of the things that satisfy this equation here. And if we think about, well, when does sine of x equal -1? Well, that's going to be at the bottom of the unit circle. So that's 3 pi over 2 plus 2 pi n. Okay. Now, we only wanted the solutions that are between 0 and 2 pi. So I want you to note here, if even with this formula with the pi over 6 in it, if we were to plug in just the number 1, a small number here, right? This is already bigger than 2 pi because you have 2 pi plus pi over 6. So plugging in 1 is too much. And let's think what happens if we were to plug in a negative. If you were to plug in -1, this is going to be a number less than 0. And right, we want it to be between 0 and 2 pi. So the only value for n that we can actually plug in here and end up with something that's between 0 and 2 pi is just n equals 0 for all 3 of these formulas. So our solution set is the number pi over 6, 5 pi over 6, and 3 pi over 2. These are our only answers between 0 and 2 pi for this equation. All right, on to another one. Okay. Part B, many students want to divide by cotangent squared of x on each side. And the reason we want to avoid this is we want to avoid dividing by 0. Okay. So in other words, cotangent squared of x, it can equal 0. So if we divide each side by it, then for certain values of x, we're actually dividing by 0. Okay? And if we do that, is what actually happens is we wind up losing some of our solutions. We won't get all the solutions that we're looking for in this equation if we divide by cotangent squared of x. So what we're going to do instead is something very similar, and the reason that I even recognize to do this is for the same reason that many of you maybe recognize that dividing by cotangent squared of x might be useful. You recognize this because you saw a cotangent squared of x on each side of the equation. Well, is what we're going to do rather than divide by cotangent squared of x is we are going to subtract by cotangent squared of x on each side. And do note, these are not like terms here because one of them has a sign of x attached to it. So we can't subtract them in kind of that traditional sense. But we can actually factor something out here. We can factor out a cotangent squared of x. And is what that leaves us with is a sine of x minus 1. And if you want to verify if this is true, if we were to distribute our cotangent squared of x back through, we'd end up with the original equation that we had here. All right, now that we have this factored and set equal to 0, we can do just like we did in the other one. This must mean that we can find some solutions by solving this equation, right? Because if cotangent squared of x is equal to 0, then all this will be equal to 0. And the other option is if sine of x minus 1 is equal to 0. That would also result in a solution to this equation up here. Okay. So let's go ahead and solve these. This one here on the right, all we need to do is add 1 to each side. And this one over here on the left, well, we just want to think about when cotangent squared of x is equal to 0. Well, this is going to happen. Let me write this a little bit differently. This is going to equal 0 when cosine squared of x is equal to 0. That's what we're really looking for here. Okay. So if we go to our unit circle here, it's up here actually a little bit, and we find when cotangent is 0, again that's when cosine will be 0. That happens what, here and here, right? This is where cosine would be 0, pi over 2 and 3 pi over 2. Let's go ahead and record that down here. So we have x equals pi over 2, x equals 3 pi over 2. And I didn't add the 2 pi in this time because we'd have the same thing happen that happened in the previous example. If you add any multiple of 2 pi to either one of these, it's either going to be bigger than 2 pi or less than 0. Okay, so all I'm really doing here in this one is writing down the angles that will make cosine of x 0, and now I want the ones that will make sine of x equal to 1. And so that's only going to happen at pi over 2. Okay. And now I want to point out I don't need to write down this solution twice. I've already written it down over here. Okay. So these are only two solutions on that interval from 0 to 2 pi. Now we're going to move on to some examples where we're going to have actually more solutions in that interval from 0 to 2 pi. Okay, we might have 4, 5, 6 solutions or maybe even more.